Welcome to this module on advanced Angular development, where you will master complex features for robust applications. Our goal is to equip you with the skills to build highly resilient and efficient Angular applications. Let us explore the core concepts of component interaction, enabling seamless data flow between Angular components. Understanding these concepts is crucial for building interconnected and dynamic user interfaces effectively. First, we have parent-to-child communication, which is a fundamental aspect of component interaction. This refers to the flow of data from a parent component down to its child component directly. Next, we look at child-to-parent communication, an equally important interaction pattern. Here, events or data are effectively sent from a child component back up to its parent component. These interaction patterns significantly foster modular and reusable component design within your applications. By carefully managing data flow, you can create highly organized and maintainable Angular architectures. We are going to learn about the @input decorator, a fundamental concept for component communication. This decorator is essential for passing data effectively from a parent component down to its child component. It specifically allows a parent component to pass any necessary data directly to its child component. You can use @input for passing both static values, which remain constant, and dynamic values that can change. Importantly, the child component automatically updates itself whenever the data passed from the parent changes. Now, let's look at a practical code example to see the @input decorator in action. This demonstration will clearly illustrate how data is passed from a parent component to a child component. First, observe the child component definition, which is designed to receive data from its parent. The child component uses the input decorator to receive data, binding the username property to the parent. This code sets up the child component to accept a username property, which it then displays in its template. Next, we examine the parent component's HTML, where the child component is actually used. The appchild selector binds the username property using square brackets, passing the parent user variable. Here, the parent component invokes the child, sending it the value of parent user through property binding. Finally, let's review the parent component's logic, where the data originates. The parent component defines the parent user variable, whose value is then passed directly to the child. This code initializes the parent user string, which the child component will subsequently display. We will now discuss the @output decorator, which facilitates communication in the opposite direction. This decorator is used for sending events and data from a child component back up to its parent component. The @output decorator provides a mechanism for child components to interact with their parents. It allows a child component to send data or events, such as user interactions, to its parent component. This is particularly useful for communicating user actions, like when a button is clicked within the child. The @output decorator primarily utilizes the event emitter class to emit custom events that parents can listen for. Let's explore a code example that demonstrates how the @output decorator works in practice. This example will clearly illustrate the process of emitting events from a child component to its parent. First, let's examine the child component definition, which is configured to send messages. The event emitter string creates an event that sends a string message to the parent on button click. This code defines an output property. Notify parent that emits a message when the send data method is called. Now, let's look at the parent component's HTML, where it listens for events from the child. The notify parent custom event is listened for, and the receive message event method handles the emitted message. Here, the parent component subscribes to the child's event, calling a method when the event occurs. Finally, we review the parent component's logic, which processes the received message. The parent component defines child message to store received data, and receive message updates this variable. This code shows how the parent component receives and stores the message sent from the child component. Now, we will explore state management with RxJS, which helps in handling asynchronous data streams efficiently. RxJS provides powerful tools for managing complex data flows within your Angular applications. Observables represent data streams that emit multiple values over time, making them highly versatile. These are crucial for handling ongoing data, such as real-time updates, or user input sequences. Observers, on the other hand, listen for changes and react to the emitted data from observables. They act as consumers, processing the values that observables produce in your application. A behavior subject maintains a state and emits its current value and updates to all its subscribers. This makes it excellent for sharing and updating state across multiple components reliably. RxJS operators are functions like map and filter used to transform and filter data streams. They allow you to manipulate data as it flows through your observables, enhancing control. Let us move on to dependency injection and services, crucial for modularizing and managing application logic. These concepts promote better organization and reusability within your Angular projects. Dependency injection, or DI, is a design pattern where Angular automatically injects dependencies into components. This means services and other objects are provided without you manually instantiating them. Angular services are singleton classes that provide reusable business logic, API calls, and shared state. They are ideal for encapsulating functionalities that are needed across different parts of your application. DI is important because it reduces code duplication, improves maintainability, and enhances testability. This makes your application more robust and easier to manage in the long run. Next, we will go through a step-by-step guide to creating and injecting a service into your Angular application. This process will help you integrate services effectively for better application structure. First, you generate a new Angular service using the command line interface, which is a straightforward process. Simply run ngenerate service myService in your terminal to create the service file. Then, you define the service using the injectable decorator, marking it as injectable. This code shows the basic structure of a service, including the provided in-root option. Next, you inject the service into an Angular components constructor, allowing the component to use it. This example demonstrates how to declare and initialize the service within your component for immediate use. Finally, you display the service data directly in the components template, showing the successful integration. This simple HTML snippet demonstrates how the services message is rendered on the screen. Today, we will explore the key differences between reactive and template-driven forms in Angular applications. Our goal is to help you choose the most appropriate form handling approach for your specific project needs. Let's start by looking at template-driven forms, a simpler method for managing user input. These forms are generally well suited for less complex scenarios and applications with straightforward data capture. Template-driven forms primarily use the ng model directive for two-way data binding within your HTML. All of the form's logic and validation rules are managed directly within the HTML template itself. Next, we examine reactive forms, which offer a more robust and programmatic way to handle forms. Reactive forms are ideal for building complex forms, especially those with dynamic validation requirements or intricate logic. They utilize form control and form group to explicitly define and manage form elements and their states. With reactive forms, all the form logic, including validation, is managed programmatically in your TypeScript code. To summarize, let us review the key takeaways you should remember from this module. These points are essential for building robust and scalable Angular applications effectively. The input and output decorators are absolutely essential for effective component communication in Angular. RxJS and observables provide a powerful way to manage state and asynchronous data streams. The behavior subject is particularly useful for sharing and updating state across various components. Dependency injection enhances modularity and testability by efficiently managing service instances throughout your app. Angular services encapsulate business logic and handle API calls efficiently, promoting code reuse. Choose reactive forms for complex validation and control or template-driven forms for simplicity.